worksheet question, whatever, and then I'll look for it and we'll go over it. So any questions? And you can try your mic and see if it works. Hopefully it does. No questions for momentum for the test? Oh, I heard someone. Oh, this is a fun recording. There's seriously no questions?
Could you go over number 16, question 16?
On which one?
On this one, the one you have now, momentum provincial exam.
Okay. Okay, a 5 kilogram object traveling at 1.6 meters per second collides with an object of unknown mass m2 traveling at 2.5. The two stick together, move right as shown. At some velocity. Okay, so in this case, because all of the final momentum is in the x direction, I'll change color. I'm going to take like the original momentum of each one in the x direction and then base it off of that. So it's going to be m1 v1 cos, no, not cos, yeah, cos 28 plus m2 v2 cos 21 equals m1 plus m2 times v. Okay, and we don't know the velocity. Let me see how many unknowns I have. Okay. So then I can start plugging stuff in. So 5 times 1.6 times cos 28 plus m2 times 2.5 cos 21 equals 5 plus m2 times v. And then I'm going to solve this as far as I can go. So 5 times 1.6 times cos 28, 7.06, and then plus 2.5 times cos 21 is 2.33 m2. And then this is going to equal, I'll probably just keep it as 5 plus m2 times v. And so I have two unknowns here. And so then I need to go to another equation, a different equation. Okay, and that equation is dealing with the original momentums in the y direction. Okay, so now in the y direction, I have 5 times 1.6 times sine 28, which is going down, plus m2 times 2.5. 2.5 times sine 21 equals 0. Okay, because there is no momentum there. And so then what you get is these two are equal. So 5 times 1.6 times sine 28 is 3.76 equals, and then 2.5 sine 21. This is 0.896 m2. And then I can solve for m2. So divide both sides by 0.896. 3.76 divided by 0.896. So then m2 equals 4.197. And then I plug that into my next equation. Okay, so 7.06 plus 2.33 times 4. Let's just call it 4.2 equals 5 plus 4.2 times v. Do I just together find the mass? Oh, we already found it, so we don't even need the v. Yeah, I guess we're done. So yeah, that's actually way easier than I thought we were finding v, but we're just finding m2. So you can just use the y because the value of the y momentum is 0. So that's easy. Okay, other questions?
I have a question.
Yep.
I don't know why it's negative 5 because I'm not sure. It's because it's in the opposite direction.
So if I make this like, if I break this into a horizontal momentum, this is like px, and this is py.
Yeah.
Notice how py is going down.
Oh, okay.
Right, and this is p2x and p2y, and so this one's going up. So I have down, up, 0.
That makes sense.
That's why.
All right, thanks.
Yeah. Any other questions? Where's the one? 13. Number 19 is a good question.
Yeah, could you go over number 19A?
Yeah. Okay, so this one is a good question because it involves momentum and energy. So that's why it's a great question. So we have a car A that's moving, car B isn't, and then they stick together after the collision. So what we need to do is deal with the momentum first. So we have P1, or I guess I can just say PA initial plus PB initial equals P final. And this is 0, so we're just going to say PA, so 8.5 times 3 equals P final. But P final is going to be 5V. Okay, it's the total mass of both cars because they stick together. So then we're going to go 8.5 times 3 divided by 5, and we get the VF as 5.1 meters per second. Okay, so that means when they stick together here, A, B, they're moving at 5 meters per second, okay, after the collision. And so then you would say at the bottom of the hill, they have EK. At the top of the hill, when they reach their maximum height and stop, that's what it means when you reach your maximum height, they have EP. And so then the EK at the bottom of the hill will equal the EP at the top of the hill. So 1/2 mv squared equals mgh. We can get rid of the mass because it's going to be 5 kilograms both times. So 1.5, or sorry, 1.5 times 5.1 squared equals, forgot the 0.1, 9.8 times h. So 5.1 squared times 0.5 divided by 9.8, and you get 1.3 meters as the height. Okay, other ones like that will be like, you'll have a cart starting at the top of a hill and then it'll hit another cart and then they'll jump off a table or something like that. Okay, so if that was the case, then you'd have to find like the speed at the ground or something like that. Okay, so you use momentum and then figure out the velocity of both cars when they hit, and then, yeah, use your conservation of energy. Okay.
Can you go over number 22?
22.
Yeah.
All right. Suppose into two unequal fragments. The larger moves at 50 meters a second. South. What is the velocity speed? Smaller. Okay. So in this case, we have one object, P initial, equals P1 plus P2 after the explosion. And in terms of vectors, it looks like this. This is your original. Your P1, let's say, is this one, and P2 is this one. Well, we're trying to solve for P2. Or you could just say P1 plus P2. So I'm going to draw it like this. P2 plus P1 equals P initial. Okay, and because it's moving east and south, this is a 90-degree angle, which makes this a 90-degree angle. And so this is the theta behind it. And then this original PI is 7 times 12. So 70, 84. 84. So this is 84. This is 5 times 15. So that's 75. And then this is going to be 2 times whatever the velocity is, because we're trying to find the velocity. And so 84, 75. You could use Pythagorean for this. Squared plus 84 squared square root. This is 112. And then divide it by 2. This is 56.3 meters per second. Seems really fast. Okay, and then you just use tan to find the angle. 75 divided by 84 to get tan.
Wait, I don't know why there's 2 in front of velocity.
So these are momentum arrows. So like this one is 7 times 12. This one is 5 times 15. This one is 2, because it's 2 kilograms, times its velocity, which we don't know. And so in your momentum diagram, you have 84 going to the right. That comes from your original 7 times 12. You have 75 going down. That comes from your 5 times 15. And then you can use Pythagorean to find 112. Let me double check that math. Squared plus 75 squared. Yeah, 112. And then divided by 2, 56.3. So it's 56 meters per second. And then you go tan theta equals 75 over 84.
But my question is, doesn't it not make sense when its hypotenuse is smaller than the opposite end, Jason?
Your hypotenuse has to be bigger. Your hypotenuse is the biggest side.
But when you divide it by 2, then
to get the velocity.
Oh.
Right, because it's asking for velocity, not momentum.
Oh.
Yeah.
I have a question about one of the examples from yesterday's notes.
Yep. Yesterday's notes. Okay.
It's example 2. It's about the watermelon question.
Yep.
Yeah, before you draw the vector diagram, shouldn't you change the equation to P3 equal to negative P1, negative P2?
I could. So there's kind of two ways to look at this. And it kind of ties back into equilibrium. It's either like because the initial momentum is 0, that's why I'm not. Because I know that if I add all 3 momentums together, I get 0. But if I had done that, so I'll do a different color. If I go P3 equals negative P2 minus P1, well, yeah, I guess it doesn't really matter. So now it's like the first piece goes up and to the right. So now it's going to go down and to the left, 64 degrees below the horizontal. So that's going to look like this. And then you're adding to that the negative of the next piece. So this is heads down and left. So now it's going to go up and right 27 degrees. And so it's going to go this way. And then the answer is going to be, what would the answer be? This is hard to draw. Okay, so 64 heads down and left, up and right, below, above. Okay. 64, 27, and then how did this work? Because my last one's going this way. P3 is going up. Oh, P3 is going down. Oh, I did that wrong yesterday. Okay, so yeah, I totally did that wrong. So this is like negative P1, this is negative P2, and this is P3. I messed that up. So with this equation right here, it's P1, so up and to the right, like that, 64 degrees. And then plus P2, which is this way. And then plus P3 equals 0 means I have to end up back where I started. So I have it going 4 degrees west of north. It should be 4 degrees east of south. There we go. Okay, so in one of them, it goes start the arrow, end the arrow, and then the next one starts at the end of the first one, so you move there, and then plus the other one equals 0, you start at that one and go down, because you're adding all 3 together, and you end where you start. This way of doing it is you add 2 of them together, so P1, P2, and then the outcome, you start where you started, end where you ended. So it's just a different way of drawing the vector diagram. It doesn't matter which way you do it.
Okay, got it. Thank you.
Yeah.
And for the next example, the battleship example, you said we don't need to get the y value, but how do you know if you only need the x values?
You kind of have to like picture it in your head. Okay, like if I were to say, hey, which way is that boat going? You would give me an x value, right? Or if I said, how fast is that boat moving? You would give me an x value. You would give me the horizontal speed. So when I ask what is the boat's change in velocity, it doesn't make sense for you to give me any y values when it's only moving in the x direction. Does that make sense?
Yeah, I think it does. Yeah.
Like this is, I got this example from, it's typically like a rail car with a cannon on it. And if that were the case, rail cars can't move down. They can only move back. And so there's no possible y value for that.
Okay. Yeah, thank you.
Mm-hmm. Any other questions from the review or any of the worksheets? No, we're good. Okay. I will post the test shortly to your OneNote pages. And just to be, just to show you what, because some of you aren't putting it on OneNote, which is like if you're using a phone, it's probably pretty hard. But if you have access to a desktop computer, I don't think you should have problems with it. So maybe you're just doing it wrong. So on your quiz page, it's going to look exactly like this with a couple pages here. All you have to do is add page and then go to insert, file, printout, and then just insert whatever your picture is or your file or whatever. Okay, that's all you have to do. Okay, and then name it. So you go to this and rename, and then you're going to name it momentum test answers. Okay, and that's it. Okay, so make sure you label it as momentum test answers. That's very, very important. Okay, I think that's it. Any last minute questions? Okay, so it's 9 o'clock now. I'll post it shortly. You'll have a couple hours to work on it. So actually more than a couple hours to work on it. So hopefully you can get it done by 12. That way you can mark them this afternoon and then include that on your interns. And that's it. So we'll do, we're going to start circular motion tomorrow. So we'll do that. And in terms of labs, I don't think we're going to do any labs. I think it's going to be too difficult to virtually do anything. And I can get you guys to analyze data or whatever, but it's just, I don't know. If I find something cool on the internet that's like a virtual lab, then I'll do that. But I haven't found anything yet. So, yeah. Okay. So I will, if you have any questions, just ask. If you have any problems, just ask. And then tomorrow we will start circular motion at 8:30 again. So I will see you guys then. Have a good day.